unit testing. Unit testing is the first level of software testing performed during the development phase. When we design our software, we break it into different components, which can also be different microservices in modern architectures. Inside each of these components or microservices, we have a collection of classes and functions that perform specific tasks. These tasks are also known as the smallest units of application. In the first level of software testing, that is the unit testing, we test these small units of individual functions and classes to ensure that they work correctly. Let's understand this with an example. Suppose you're working on a hospital management system which has several microservices, like one for authentication, another for appointment, another one for booking, one for billing, and many more. Now suppose one of your microservices is responsible for billing. In this service, you will have various classes or functions that handle different tasks. One such task is the calculation of the final bill. Suppose there's a function calculate final bill which takes into account different medical tests, doctor fees, taxes and discounts. This function accepts patient billing details as the input and calculates the final bill accordingly. Now this is just one function among many others in the billing service. Each function serves a specific purpose, so it's essential to ensure that each one works correctly. This is where unit testing comes into play. For the calculate final bill function, we would write different unit test cases to check if it functions correctly in various scenarios. For instance, we would test this function by supplying different sets of arguments and checking if it returns the correct value. For example, in the first unit test, we can provide a list containing different expenses like charges for multiple medical tests, doctor fees, and taxes info to check if it calculates the correct total. In another test case, we might pass a bill with just one test and tax details to ensure that it still works correctly as expected. We would also write a unit test case where no services are provided. Example, an empty bill to confirm that the function returns a total of 0. The goal of these unit tests is to verify that the calculate bill function behaves as expected under different conditions. Now imagine that your billing service contains 15 different classes, each responsible for different aspects of billing process. One class might handle taxes while another might handle discounts or fetching patient data. You would need to write different unit tests for each of these classes and their respective functions. The benefit of writing unit tests early is that they act as a safety net. If you later need to modify the code, for instance, to fix a bug or introduce a new feature, you can run the unit tests to quickly verify that nothing is broken. Now let's talk about some of the advantages of unit testing. The advantages of unit testing are: first, catches bugs early. Unit testing allows the developers to catch the bugs in the early development process. When a developer makes any change to the code, they can run the existing unit test cases to see if the new changes have not broken any existing functionality of the function or class. They also add new unit tests to test the individual functions or classes as soon as they are written. Early detection of errors can prevent larger issues at a later stage. Second, improves code quality. Unit tests promote cleaner and more modular code. Code that needs to be tested through unit test cases should be modular. So, to make code unit testable, developers often create smaller, more focused functions that are easier to test, which leads to better overall quality. Third, facilitates refactoring. Large applications are usually the result of the efforts of hundreds of developers over a long span of time. Code will be modified by several developers over the years. If there are unit test cases in the code, then it makes refactoring or modifications easier. When changes are made to the code base, running the unit tests ensure that no existing functionality is unintentionally broken. Fourth, documentation. Well-written unit test cases serve as a form of documentation. They show how each function is intended to behave, making it easier for the new developers to understand the code, such as what different sets of input parameters can be provided to a function and what the output will be. This makes the life easier for future developers as well. Fifth, faster debugging. If a bug is introduced during a coding phase, unit tests can help pinpoint the exact location of the issue, making debugging faster and more efficient. Well, there are some of the advantages of unit testing, but it also has certain disadvantages. Let's look at some of the disadvantages of unit testing. First, it's time consuming. Writing unit tests can be a time-consuming process, especially for complex code bases. Developers need to balance the time spent on testing with the time spent on writing code. Second, maintenance overhead. As the code evolves, unit tests must be updated to reflect changes in the code base. For example, if we enhance an existing functionality by adding a new parameter, then all the existing unit test cases for that function will fail and require modification as well. This adds to the maintenance burden. Third, false sense of security. Passing unit tests doesn't guarantee that the entire system will work correctly in all scenarios. Unit tests only cover individual classes or functions, not the complete component or the interactions between the components. This needs to be tested separately in the next levels of testing. Fourth, difficult for complex logic. Unit testing can be challenging for complex logic that relies on multiple dependencies such as external services or databases. Now let's talk about the different tools used for unit testing. Different programming languages provide different frameworks for unit testing. For example, in Java, we have JUnit framework and in Python, we have PyTest module. Now, let's talk about what are stubs and mocks in unit testing. In unit testing, we test individual functions or classes, but in real-time scenarios, these classes or functions are dependent on other classes and functions. Therefore, when writing a unit test case for a unit that is a class or a function, it is necessary to isolate it from its dependencies so that it can be properly unit tested. This is where stubs and mocks come into play. Stubs and mocks are the two essential components of unit testing that we need when implementing unit test cases in complex and large code bases. Let's understand them one by one. First, what is a stub in unit testing? A stub is a basic version of a class or a function that behaves like a real thing. But instead of running the actual code, it uses fixed hard-coded values to mimic how that class or function works. It helps remove the dependencies when testing a unit so that one can test one part without worrying about the rest. For example, in our hospital management system, imagine the calculate final bill function that needs to pull patient data from a database to apply specific discounts. When you're writing unit tests, you don't want to depend on the actual database. So you create a stub that returns the preset data. This way, the stub acts like the database but with the fixed values, letting you test the billing function without relying on the real database. Now, what is mock in unit testing? Mock is like a stub but with more features. Besides giving you the fixed data, it also keeps a track of how it was used in the test. For example, in our hospital management system, you could create a mock of a tax calculation service that records how many times it was called and with which arguments. This helps you check if your billing function interacts correctly with other parts of the system. Using stubs and mocks allows you to isolate the function you are testing, making sure your tests focus only on that specific piece without interference from the other parts of the system. So, to summarize, unit testing focuses on testing individual pieces of code such as functions and classes to ensure that they work correctly in isolation. It helps catch bugs early, improve code quality, and making refactor easy. Writing good unit tests requires careful planning and understanding of how to isolate code units using stubs and mocks. I hope this gives you a clear picture of unit testing and its importance. If you have any questions or need more examples, feel free to ask. Don't forget to like and subscribe for more videos on software testing.